Welcome back to All This Math. This is Professor Parker. Make sure you're subscribed to the All This Math YouTube channel. Make sure you drop a comment down below. Make sure you like the video. Make sure you share with some other people. Also, make sure you have a copy of How to Use All This Math Volume 1 that's available on Amazon right now. How to Use All This Math Volume 1. Go check that out. All right. What are we getting into today? Today's lesson deals with what we call piecewise functions. Piecewise functions, right? Once I explain this to you, it's going to be very easy for you. And I enjoy explaining concepts like this because this is one of them things that when I was in high school and I got introduced to this, it intimidated me, right? It looked scary. It looked difficult. It looked, hard to solve. You know what I'm saying? It looked like that. And I kind of bought into that propaganda. But once I explain it to you and break it down, I'm gonna show you like how it's really not that difficult of a concept. And these graphs are pretty easy to do. All right. Once you understand how to do them, they're easy. All right, so what we got here? So first, let's talk about why they call it a piecewise function, because I like to always make sure we on the same page. We establish definitions so we have common ground. Why is it called a piecewise function? Everything that you'll encounter in math, whether it's algebra, geometry, pre-calculus, calculus, statistics, it has a name for a reason. And oftentimes, if you know why it's called that, then that'll also help you to understand the process of solving the problems that are involved with it. So a piecewise function is like you're taking a piece of each of the functions and you're going to graph a piece, not the whole function, right? But just a piece of it, right? It's like you take a piece of candy, a piece of cake, maybe a piece of chicken, a piece of a sandwich, whatever, right? You take a piece of it. You don't take the whole thing. We only dealing with a piece. All right. So what we got here, right? We got f of x, right? F is the name of the function, and the function has a certain value based on upon whatever the value of x is that we input, right? X is our input, right? F of x and y are synonymous. The variable y is synonymous with f of x, right? F of x and y mean the same thing. They're what we call interchangeable, right? So we got f of x is equal to, and then you see this brace right here, right? Because instead of what we usually have is just, one function, right? Normally we might just see f of x is equal to x, and then we graph that. But instead it says, all right, well, f of x is equal to x when x is less than 0, and f of x is equal to 5 when x is greater than or equal to 0. So this part right here is real important. So when you look at these problems, you want to separate this part from this part, right? This part is what we call the where, right? Or at least what I call when I think of how to do these problems, I'm like, all right, where is it going to be this at? So this is the what, this is the where, this is the what, this is the where. Just like when you was in elementary school and you learned about writing, you know what I'm saying? Like maybe writing an article or writing an essay, you think about the who, what, when, where, why, and then the how, right? 5 W's, you know what I'm saying? So in math, we can use that too to gain understanding. So this is the where, and this is the what, right? So the what is the x and the 5, all right? But it's not going to be x. We're not going to have the whole x. We just want to have part of it. And when we think about graphing, a graph is just a picture, right? It's what it looks like. When we graph x or f of x is equal to x, that's written out using letters as symbols, right? But we could also draw a picture of it and show you what it looks like. All right, it's going to be a straight line because this is to the first power. This is what we call a linear equation or a linear function because the biggest exponent that we don't see is a 1. X is the same thing as x to the first power. And because the exponent is a 1, the first power, that means that the graph is going to be a straight line. Same thing with f of x equals 5. This technically, this is going to be a straight line too, because we could imagine that this was the coefficient of x to the 0 power. Since x to the 0 power is equivalent to 1, that's something you know when you understand properties of exponents, right? X to the 0 power is the same thing as positive 1. The whole x turns into a positive 1. So that's just like saying 5 times 1, which would just leave you with 5. So this is still technically a linear equation. F of x equals 5. So this is what we do. We say, all right, well, this is how I do these, right? And it's a lot of different ways to do these. Again, I say that all the time in all these videos. That's the thing I like about math is that we got options. Math gives us options. We don't got to do no problems just one way, right? Look at the where, right? So it says x is less than 0. So what I do is on my graph, hopefully you're using graph paper when you do this, right? If not, if you're on notebook paper, just draw your graph, draw a vertical line for your y-axis, draw a horizontal line for your x-axis, and try to make your spaces as equal apart as possible, right? So if x is less than 0, right? We find where that is. So here's 0, right? The y-axis is 0, right? The y-axis is where x is 0, right there. Here, x is +1, +2, +3, +4, +5, 6, 7, 8, -1. X is -1, -2, -3, -4, -5, -6, -7, -8, -9, right? So we're saying, okay, when x is less than 0, so that means when x is negative, then we're going to graph a part of this function, f of x equals x. So we say, so really what we need to know how to graph functions, right? So how do you graph functions, right? So the way I do it is I'm like, again, I told you already that f of x and y were the same thing. So I think of this as y equals x, all right? So if I want to do y equals x, it's a bunch of ways to graph, linear equations, but we know that my y-intercept is 0 because it's like x plus 0. And I got other videos that show you how to graph linear functions, right? Because that's a skill you got to already know. In order to do this, you got to already bring some stuff to the table. You got to already bring that skill to the table. You got to already know how to do this, how to graph just this, right? Y equals x. And you got to know that the y-intercept is 0 and y equals x. So if you got y equals x, the y-intercept is 0. So that means the y-intercept will be right here at the origin, right? And then the slope is going to be 1. How do I know it's 1? Because what's the coefficient of x? The coefficient of x is 1. So that means that m is equal to 1, and we make it look like a fraction. Make it 1 over 1, right? So that tells you that my slope means I'm going up 1 space between points. Up 1 space and to the right 1 space. Up 1 space to the right 1 space. Up 1 space to the right 1 space. All right? But look, so normally, if I was just graphing this, right, y equals 1x plus 0, which is the same thing as y equals x, which is the same thing as f of x equals x. If I was graphing this and it was the only function I was graphing, I would do this. I would have, now I'm gonna use black for this, right? I would start with my y-intercept right there, boom, and then I would go up 1 and over 1, boom, and I would go up 1 and over 1 again, boom, and I would go up 1 and over 1 again, boom, and then I grab my ruler or my yardstick, right? My meter stick. This is a meter stick, by the way, right? Yeah, got this from a school I used to work at, teach at, or whatever, right? And then I would draw a straight line, as straight as possible, right? Now, one of the things that you want to memorize actually is that whenever you see y equals x, you know that's going to be a vertical line. Not a vertical line, I'm tripping. You know it's going to be a diagonal line, like a diagonal line through the xy coordinate plane, right? Whenever you see y equals x, it's going to be a diagonal line because your slope is +1. Now, how do I know that? Because I've done thousands of these problems, right? It ain't like I just was born, 45 years ago, just knowing this. Nah, that ain't how it works. You got to put the work in, and I put the work in, right? So what that means, I say that because I want you to understand you too can be as proficient as I am at this work if you practice. It's really about the practice. Somebody got to teach it to you, or you can be self-taught. You got to learn it and then practice. Learn it and then practice, and you're gonna be able to flow just like I can. All right. So now you got this line right here, right? This is f of x equals x. All right. Under normal circumstances, we would just rock with this. But again, where is it at though? We only want a piece of this function. We don't want the whole thing, right? Just like when you're not that hungry, you might not want a whole sandwich. You want a piece of the sandwich. You know what I'm saying? I just want a piece. I don't want the whole thing. Now I'm cool. You might want to split it with somebody. Like, yo, let me just get a piece of that, right? Piecewise functions. I only want a piece. I don't need the whole thing. I just want a piece. So I only want a piece of this graph. I don't want the whole thing. I want it where, but what piece do you want though, right? You know what I'm saying? Like somebody like, yo, Larry, take a piece of this. And then you decide, yo, what piece do I want? You be looking, sizing up the food or whatever, right? What piece do you want? I want the piece where x is less than 0. So what I do is I find where x is less than 0. So all this is x greater than 0 because these are all positives. Think about the x-axis. That's +1, +2, 3, 4, 5, 6, 7, 8. So I'm going to erase that. I don't want none of that, right? We don't want none of that, right? So we're going to erase all that, but also we're going to do this too. It says x is less than 0. So that means x is not equal to 0. So we don't even want 0. So what we're going to do is we're going to do this, right? We're going to draw like an open circle right here. What they call an empty circle, right? So we're going to have an empty circle. So look what we did. Now we got the graph of f of x equals x, but we only got a piece of it. That's why it's called a piecewise function. We only got a piece of it. And what piece is that? The piece that's less, where x is less than 0. So here we got all the x values are less than 0. X is -1, x is -2, x is -3, x is -4, -5, -6, -7, -8, -9. See how that works? And it's going to go on forever and ever and ever to negative infinity, right? Which is cool. But again, we only want the piece that's not less than 0. Now, what about the second function, right? The second function, we got f of x is equal to 5. So if I had f of x is equal to 5, what would that look like? That would look like this, right? I would rewrite it. It's like graphing y equals 5. Now, there's a rule, right? Whenever we're graphing a function, right, and it's like y equals a constant, a number is a constant. It could be a whole number, it could be a fraction, a decimal, a positive number, a negative number. That's a constant. It's a 5. Like there's no variable. There's no x variable, right? We got y equals 5. As a rule, we just know that this is going to be, the graph of this is going to be a horizontal line. That's something that I suggest you just memorize, right? That's going to be a horizontal line. All right, horizontal line. But horizontal line where? Where y is always 5. Again, math is a language, right? Y is 5 or y is always 5. Where they do that at? We go to the y-axis. You find +5 on the y-axis. So I got +1, +2, +3, +4, +5. Boom, right here. Right? That's 1 point. So y is 5. But y is always going to be 5. So normally what I would do, right? If I was graphing this and this was the only function that I was doing, I didn't have two functions, right, to graph at the same time. I would just graph this, y equals 5. I would say, all right, it's going to be a horizontal line, and every point has a y value of +5. That's what makes it horizontal. Because if I draw a horizontal line like this, right? I draw a horizontal line like this, and then I do that, draw my arrowheads, right? Let's say I do that, right? Now, every one of these points on this line, it's an infinite number of points on this line, but every one of these points has coordinates. No matter what the x value is, whether it's -1, -8, +9, +342, because it's a horizontal line, think about it. The y value is always going to be 5. The y value is always going to be 5, no matter what. The y value is always going to be 5. That's what makes it horizontal. Because the y value ain't never going to be 4, it ain't never going to be 3, it ain't never going to be 6 or 7 or 8 or 9. It's always going to be 5. The y value is always going to be 5, right? And since the y value is always going to be 5, that's why the graph looks like this. It's horizontal, right? If we had x equals a constant, it would be a vertical line for the same reason, right? It'd be the same reason. All right. So now, but look, we only want a piece of that. We don't want the whole thing. We just want a piece of it. All right. So that's why it's called a piecewise function, because we only want a piece of it. But what piece do we want? We want the piece where the x values are greater than or equal to 0. So where they do that at? From here, that way, right? So we don't want none of this, because these are all negative values for x. These are all negative values. We don't want the piece of the graph where x is less than 0. We want the piece of the graph where x is greater than or equal to 0. So get rid of that, right? We're going to get rid of that. And then we're going to do, draw that. And this is going to be a shaded in circle, right? It's going to be a shaded in circle, right? And it still satisfies, it's still a function. It's a piecewise function. It still passes what you probably learned about already, the vertical line test. It still passes the vertical line test, because if I draw a vertical line, it's going to hit this point, and then it keeps going. Notice how this is an empty circle. This ain't shaded in. This is an empty circle, right? So it still passes the vertical line test. So it don't hit 2 points. No vertical line can hit 2 points on the same graph, right? So because of that, that lets you know that it's still a function. So this is a piecewise function. So basically, in summary, what we did was we graphed this function, but f of x is equal to x, but we only wanted a piece of it. We wanted the piece that goes from here down here, from 0 to the negative side because x is less than 0, right? And then we also graphed f of x equals 5, right? But we only wanted a piece of that. We just wanted the piece that is greater than 0 or and also equal to 0. So this is equal to 0, and these are all the values that are greater than 0, right? Off to the right. So that's what we wanted. So again, this is really like piecewise functions is really about like just understanding the language of algebra. If you understand the language, I mean, if we first look at this, you never seen it before. This can be intimidating. That's part of the problem. That's what you know. What I'm saying, like, I ran into that problem when I was in high school, like many years ago, right? But if you break it down and you understand, okay, this is where it's at, this is what it is, right? Just know how to graph that. But you got to know how to graph functions, though. You got to know how to graph functions. So with a piecewise function, and sometimes it's going to be examples where you might have 3 different functions or 4 different functions, right? And they might not all be linear. One might be linear, one might be quadratic, one might be a radical function, one might be a reciprocal function. You might have a whole lot of stuff going on. You might have like some type of like you might have a trig function, but you got to know how to graph functions. So as long as it's kind of like doing 2 problems in one, because if somebody just gave you like graph f of x equals x, you wouldn't have had no problem doing it. You would have just drew the diagonal line, boom, you'd be done. And then if somebody gave you, okay, number 2, that was number 1. Now number 2, graph f of x equals 5. Okay, you're gonna draw your horizontal line through 5 on the y-axis, right? You're gonna be done. That's on 2 separate graphs. But now what we're saying is, what if you could graph both of them on the same graph? On the same graph. And only take pieces of those, right? But what pieces though? This right here, some books may call it the domain restriction or just the domain in general. The domain of this function is x is less than or equal to 0. So these are all the domain is all your x values. So any x value less than 0 is cool, right? That's what you want. So you're gonna draw that. You're gonna graph that. But for f of x equals 5, you want the x values that are greater than 0, that equal to 0 and are greater than 0. So you're gonna keep the 0. That's why we got the shaded in circle at 0, right? At 0, 5, right? But then we want all the positives because greater than 0 is positive. So that's why we're going over here. That's why we're not going that way, right? You should always be able to explain everything you do in any math problem. All right. So that's that. Remember, make sure you subscribe to the channel. Make sure you drop a comment down below. Make sure you like the video, share the video with some people. Also, grab a copy of How to Use All This Math Volume 1, available on Amazon right now. All right. I'll see you on the next video. Peace.